This is a question from Andrew, wondering what would happen if the Earth and all land objects suddenly stopped rotating while the atmosphere retained its speed. First of all, almost everyone will die, and then the real catastrophe will begin. At the equator, the Earth's surface moves at a speed of about 470 meters per second, slightly over 1,000 miles per hour, relative to its axis. If the Earth stops, while the air continues to move, the air at the equator will move over the surface at a speed of 470 meters per second. For reference, the speed of sound is 343 meters per second. The wind will be strongest at the equator, but all living beings and objects between 42 degrees north and 42 degrees south will also face sharp supersonic winds. These strong gusts of wind will last only a few minutes on the surface, before friction with the ground slows them down. However, these few minutes will be enough for almost all human structures to turn into ruins. Even structures strong enough to withstand the wind will find themselves in dire straits. As comedian Ron White said about hurricanes, it's not about the wind blowing, but what the wind carries. Imagine you are in a massive bunker made from a material that can withstand winds of 1,000 miles per hour. It's not bad, and you would be safe if you were the sole owner of the bunker. Unfortunately, you likely have neighbors, and if the neighbor's bunker upstream is less securely anchored, your bunker will have to withstand the supersonic impact from their bunker. My house in Boston is far enough north to be just outside the zone of supersonic winds, but the wind here will still be twice as strong as in the most powerful real tornadoes. Buildings will still be torn away, uprooted and rolling across the landscape. Winds will be weaker at the poles, but no human city is far enough from the equator to avoid destruction. The northernmost city on the planet is located on the island of Svalbard in Norway, and even it faces winds equal to those observed in the strongest tropical cyclones. Nevertheless, the human race will not go extinct. Yes, very few people on the surface will survive. The flying debris will destroy almost everything, but many people underground may well survive this event. There will also be other fortunate survivors, such as scientists and staff at Imona Scott's research station at the South Pole. The surface of the Earth at the South Pole does not move relative to the Earth's axis as it is on the axis. People there will simply lose connection with the outside world. They will likely be confused until someone notices that the sun has stopped moving across the sky. Then, they will be truly puzzled. At the equator, everything will become truly strange. The wind racing over the oceans will mix and spray the top layer of water. At some point, the ocean's surface will simply disappear. It will be impossible to determine where the spray ends and the sea begins. When the energy of the powerful wind begins to dissipate, it mostly turns into heat. A lot of heat. But the oceans are cold. Beneath the thin surface layer, the temperature is fairly uniform and about 4 degrees Celsius. The wind rising from the surface will heat up upon contact with warm air and ascend into the warmer layers of the atmosphere, allowing new cold sprays to rise and warm up, and so on. This subsequent turbulent mixing will likely cause global storms over the oceans. The wind will also have inertia, which will be transmitted to the waves that will roll across the world from west to east, and every western shore will face the largest storm wave in world history. It will be like a combination of normal wind-driven waves and a tsunami. A turbulent wall of water rushes to the shore, reaching several miles inland in some places. Eventually, a dense layer of fog forms over the cold ocean surface. This usually leads to a sharp drop in global temperatures, and they will indeed fall on at least one side of the Earth. If the Earth completely stops, the normal cycles of day and night will cease. The sun will not completely stop moving across the sky, but it will slow down significantly. As Earth's orbit describes a circle, we will see the sun rise and set exactly once a year. Although, of course, not exactly once a year. The inertia of atmospheric winds will be transferred back to Earth, slowly starting to rotate it again. Since the atmosphere is significantly lighter than Earth's, one complete revolution of Earth will now take about 3,000 years. Thus, in practical terms, a day lasting a year will become the norm. Earth will experience 6 months of day and 6 months of night. On the side where it's day, the surface will heat up under constant sunlight, while on the night side, the temperature will drop sharply. Although the length of the day will change, the length of the month will remain the same. The moon did not stop orbiting the Earth. In fact, our faithful companion will partially correct the consequences of Andrew's actions. I remind you, it's all because of Andrew. Previously, thanks to the moon's gravity, The tilt of the Earth slowed our rotation while simultaneously raising the Moon to a higher orbit. After Andrew stopped the Earth's rotation, the Moon's gravity will slowly pull the Earth and accelerate it again. Eventually, someone will be able to ask the question, what if the Earth suddenly stopped rotating? Thank you, Moon.